Hi, welcome Abhijit. Thank you for starting the recordings and we'll begin now. I'll just stop sharing now and you can take it over.
Yeah, sure. All right. Hello, everyone. Welcome to this by Pinet Labs Private Limited on SD-WAN. Let me share my screen with you all and start my camera. I hope I'm audible to you all.
Yes, you're audible. Guys, you can type in the chat box if it's audible or if any question, you can keep asking in the chat box.
That's great. And now I hope you can see my screen as well, where I have opened up a presentation part in which we are going to discuss a couple of topics from SD-WAN. So, as you all are familiar, that we are here in order to discuss about SD-WAN, and this is kind of a topic that has been pretty trending in the current world scenario. But in this particular webinar, our main motive or focus is to discuss what has been the industry trend and why SD-WAN is becoming such a popular topic, because almost every company is looking forward to implement SD-WAN solutions in their production environments, right? So we're going to talk about what is the requirement and why everyone is actually looking forward to implement SD-WAN. And I'm also going to demonstrate you about the lab scenario, because we are some of we're bringing you guys with the hands-on lab that you all can do, because as you all know, SD-WAN actually requires a lot of high resource capabilities in order to implement the solution in a production environment. So not everyone gets able to do the labs or hands-on practice whenever someone learns about SD-WAN. Right, so we are also catering you hands-on labs and hands-on practice lab that you can actually interact with the real devices or the real operating systems that you can deploy directly into the production environment. But before talking up or before starting up, I'd like to give you an introduction about myself and the company that I'm representing. So my name is Abhijit. You can call me AB if it's hard to pronounce for some of you guys. And
Abhijit,
uh, yep.
yeah, Abhijit, sorry to interrupt, but a lot of people are getting issue with the sound quality. When I'm getting left some disturbance, the sound quality.
Well,
I
there
uh,
shouldn't be any
the
issue.
server, the issue with the
Just
SD-WAN server, I think I can hear that.
is it any better now?
Echo. There's an echo coming.
I
Can you
hope
try
it's better now.
again?
You guys can reply me in the chat. Yeah, I've reduced the echo as well. I hope that's fine now.
Yes, yes. Now it's very much better. For me, it's better. Guys, how is it for you?
Perfect.
Yep, it's better.
Perfect.
Great.
Perfect.
Thank you so much for taking the
So we
feedback.
were discussing about the SD-WAN itself, and I was talking about and giving my introduction to you all guys that we are talking about SD-WAN's lab. And to talk about myself, my name is Abhijit, and you can call me AB, and I'm representing a company called Pinet Labs Private Limited, in which our key USP is about to deliver automation solutions and trainings on network automation, along with various automotive tasks or various automotive solutions that are coming up by different vendors. So talking about Cisco have came up with SD-WAN solutions, ACI solutions for data center, and various other tools like Meraki for wireless, DNA for enterprise network, and so many other tools that are coming out there, right? So when we talk about the same, I have been delivering trainings since last 8 years, and I have an experience of delivering trainings under the technology of routing and switching, under the technology of data center, under the technology of service provider, and some of the topics of security. Now, when Cisco came up with the largest, you can say, change that was actually announced And I would say the change was announced in a way that has never been announced in the last 25 years. So this was the latest, and this was the biggest change that Cisco made to its certification tracks. And they Cisco came up with various other technologies as well that actually got introduced. So when we talk about the same, then SD-WAN was one of the technology, and network automation was another technology. Now, when we talk about SD-WAN itself, then SD-WAN can actually be used in an automated way as well, because it's used in order to minimize the amount of manual configuration that you actually need to deploy onto the production environment. So I generally, you can say, catched up on the recent trends, and then since last 2 years, I've been delivering trainings onto these latest technologies that have been out there. Okay, so that's what I've been doing, and I've delivered almost trainings for more than around 1200 hours, and you can check out my profile onto the website as well. That will kind of give you more information about the technologies that I have delivered and what are my skills and certifications. Okay, and then that's what I would say my introduction would be. And if I talk about the learners introductions, it means that who should actually enroll for this particular course, or who should actually move on for the technology that's out there. So anyone who has the routing and switching experience, or anyone who is familiar about the basic knowledge of how WAN networks actually operate, anyone who has the ability to understand how routing and switching environments actually work, he can go on and learn about this technology, and it's very good technology to understand how ISP networks actually operate. Whenever a multinational company or a national company has various other sites that are being deployed, one can be geographically at some place. Let's say one office is in New Delhi of India, and the other office is in Dubai, and the third office is in London, and so on. So whenever you want to manage the network infrastructure of the geographically dispersed company locations, such kind of things actually can be managed greatly with SD-WAN. So you can say that in that particular scenario, you will need SD-WAN solution to greatly be able to manage the complex network that your company might have. Right? So that's what we're going to get an introduction to. And if I talk about the webinar outlines, then I'm going to give you an introduction of SDN. We're going to talk about, because SD-WAN is kind of a children of the major technology that is called software-defined networking. Okay, so we're going to talk about that SDN. We're going to talk about networks as of today, which means what have been there till now. And then we're going to talk about evolution of WAN networks. And then why do we actually need to implement SD-WAN into the solution? And then I'm going to give you a brief demo about how the labs can actually be done and how the topology actually looks like when we talk about the SD-WAN solution. And then I'll be answering some of your questions, and we'll show you about how our training modules are customly tailored for the requirements that you guys can have. So let's move on and talk about the introduction to SDN. Now, talking about SDN, almost everyone is familiar, or everyone is aware about what is SDN. SDN actually stands for, you can say, software defined networking, right? So when you talk about software defined networking, what does it actually mean? In the previous, you can say, webinar that I conducted, some of you might be joining from that as well, but I must tell you, and again tell you, that software defined networking is not something that have recently came up. The term has been in the industry for almost last 15 or 10 or 15 years now, and almost everyone has heard about it, that there is something called software defined networking. Now, what is this software defined networking? And as the term says software, it doesn't mean that only software engineers or application engineers or application developers can understand it. It's nothing like that. So if I talk about it, then software defined networking is something that you should be able to manage the entire network with a piece of software. Because earlier, what happens if we have multi-site deployment, or if you have a network deployment that actually is dispersed geographically on different locations, probably you might have one office, let's say in New Delhi. So this is one of your office that is situated in New Delhi. Okay, and then you have some other office that probably might be situated over here, and let's say this is your Dubai office, and then there might be someone who is sitting over here. That is your London branch. Now, whenever you have such kind of deployments, you probably would be taking the help of the ISP network. Let's say this is the ISP cloud and you are connecting all these branches with the same or different ISP that's available there. Now, you can consider one of your site being the data center hub. Let's say this is your DC headquarters, and majorly all the resources are stored into this data center. Geographically, it can be different. It can be Dubai, it can be London, it can be US or something else as well. Now, when I talk about it, then you can say that you might have a couple of routers over there. You might have a couple of firewalls over there. You might have a couple of, you can say, switches over there, right? And you can connect all these devices in a mesh fashion as well. And then you might have certain applications that are being deployed. So these are all the applications. Now, whenever a company is functioning, you can say that the data center is a place where all the applications of that particular company is stored. Your company might be running a CRM server, your company might be running a SAP solution, your company might be running an email exchange solution, your company might be having some HTTP services going on and some SQL servers and various other you can say applications and virtual machines are being provisioned. And all of these images or all of these softwares or applications are stored into the data center. Now, how it works is it's not something like the employees will be sitting into the data center. Of course, they won't be sitting into your data center, right? So what's going to happen is your employees are going to sit rightly over here, in some in Dubai office, some in London office, and there can be multiple branches or sites deployed like that as well. Okay, so whenever you have a scenario like this, you might have a router over here, you might have another router over here, and these router kind of acts as the edge routers. So you have edge over here, you have edge over here, and you have edge over here as well. Okay, these routers will be called as edge routers that actually represent to the entire branch that you're sitting inside. Make sense? Now, there are a lot of employees that actually has the reachability of reaching out to this edge router. Make sense? So you all can actually reach out to the edge routers that are there. And whenever you are able to reach out to the edge router, then you can say that in that particular case, you need to be able to reach out to the solutions that are out there, which means that people who are sitting in Dubai office, they need to access the resource that is stored into the New Delhi office. Or people who are sitting in London office, they actually also need to access the resources that are stored into the New Delhi office that are out there. Make sense? So in order to access such things, you actually take help of your ISP in order to securely be able to reach out to your resources. And recently, a solution that you actually, or a solution that a lot of production environments used to use is something called MPLS, multi-protocol label switching. So MPLS is kind of a solution that a lot of ISP used to, you can say, provide to the lot of its customers. So let's say there is an ISP, for example, AT&T. And AT&T is a company that actually covers a lot of physical network provisioning that has been there laying their undersea or under submarine cables and connecting the entire world together. So how it works is your company will request to the ISP in order to connect one of its sites to its MPLS network or to its MPLS fabric. And by using that, you are actually using a public infrastructure, because what you have over here, the entire network or the entire you can say ISP fabric will be called or will be referred as public infrastructure, because it's not only you to whom the ISP is making its infrastructure available. It's the entire customer, you can say, fabric of that particular ISP to whom the company or the ISP has made the infrastructure available. You're one of their customer. So it's possible that your data is traveling on one of its link, and there are other data or other customers' data that is actually traveling on the same link as well. So how would you, in order to ensure the security, in order to ensure the quality of service and quality of link, and in order to you can say provision the 100% uptime or service link agreements. There are a lot of other things that comes into consideration whenever you kind of build up a WAN connectivity with multiple sites that you have. So whenever you need to connect your different sites, till now or till some years before SD-WAN coming in, MPLS was the best solution that was out there. But as network started becoming complex with the recent trend of cloud, because everything or every application that you now have is being shifted to the cloud infrastructure. You do not really want to keep the CRMs or the SIP applications, the email applications, the HTTP applications or SQL applications into the data center. You do not really want to do that, right? And what you need to do is you need to shift those particular applications to the cloud, which means it can be Google Cloud, it can be AWS, it can be Microsoft Azure, or it can be your private cloud as well, because you can have a public cloud and you can have a private cloud. So MPLS was being very costly in order to, you can say, implement such things. And if you like MPLS, you used to also take a lot of time in order to be implemented. Which means if you're coming up with a new site, let's say your company is actually coming up with a new site, and that new site is going to be deployed into USA. Now you need to tell the ISP with which your other sites are connected. You need to tell that particular ISP the like 2 or 3 months before, and that we're coming up with a new site and we need that particular site as well to be connected with the MPLS service of yours. So that ISP will take like weeks and months of time in order to set up the MPLS solution and bring that particular site into the MPLS fabric that it has. So and whenever you need extra bandwidth, whenever you need extra quality of service, and your application needs to be provisioned with some of the other services that would ensure the 100% uptime, or you can say 0% downtime for your network, you need to pay hefty amounts to ISP in order to get those services. So that's why these were kind of the top-notch limitations that you had. So when we talk about this, there is another limitation that you have. So this is how the standard WAN used to work, or this is how the standard WAN networks or site connectivity used to work. Now, if we talk about the same, that how SDN actually plays role, because this is something you can say that is, you can say, this is something you can say as networks as of today. But if you talk about SDN, then why everyone is actually moving towards SDN? So when we talk about that, you can have a same solution. For example, let's say that there is, I'll show you a topology that would actually give you a better idea. That whenever, let's say you have a router that is actually being connected, and this router is connected to one of the firewall and another firewall inside your organization, and then you have some layer 3 switches that are being actually connected over here, and then you have some layer 2 switches that are actually being connected, and these layer 2 switches are actually being used in order to connect to the VM like this. And then you can have a different branch altogether, like this R1 is connected again to ISP network, and then this ISP network is connected to multiple sites that are out there, right? So you have R2, you have R3, and you have R4, and all of these sites are actually connected over here. And then there are multiple people who are accessing that particular internet service that's out there. So tell me one thing, that if you have a lot of people, let's say around 100 users that are available here, 100 users that are available here, and 100 users that are available here. The numbers, of course, might vary, but yeah, if you have these many users, and then as I told you that your organization might be using different solutions. So the solutions can again be SAP, the solution can be ERP solutions, email solutions, and various other solutions that are out there. And all of these solutions are actually being hosted onto the virtual machine server that you have here. Okay, that's an ESXi server, let's say, that you're using there. Okay, now there is a new application that your company is purchasing. And if your company is purchasing a new application, then what's going to be the issue is whenever your new virtual machines or that new application is being hosted onto this particular virtual machine server, then in order to make it available for all the other sites over here and over here, you need to actually configure a lot of other devices that are available there, because you have your layer 2 switches being deployed, you have your layer 3 switches being deployed, you have your routers being deployed, firewalls being deployed, load balancers being deployed, and all of these devices needs to be configured with some of the other configurational changes, which means that the new application is actually, or the new application will actually be hosted onto this virtual machine, right? So this virtual machine needs to be configured with new VLANs, right? The virtual machine needs to be configured with new subnet masks. The virtual machine needs to be configured with, you can say, new ACL access control list, or you can say new firewall configuration, and then new load balancing configuration, and a lot of other configuration that actually needs to be done. Now, whenever we talk about these configuration, the configurations are actually divided into two parts. Okay, if you have any device, that device, let's say there is a router. This particular router will have three planes. One, you will have a control plane. Second, you will have a data plane. And third, you will have a management plane. Okay, almost every device has these three planes. Now, management plane or control plane, you can say, talking about the first. Control plane is responsible for provisioning all type of configuration onto the device, which means if you're creating a new routing policy, let's say you're configuring OSPF on your devices, then control plane is responsible for provisioning that particular configuration onto the device. Okay, data plane then copies, data plane is responsible for forwarding traffic from receiving it on one interface and forwarding it to some other interface. Make sense? And then after that, management plane is actually responsible for being able to manage that particular configuration over there. So when we talk about all these planes are responsible for sending out the information, or for configuring out the information or configuration onto whatever devices that are out there. Now, when we talk about the traditional approach, then that traditional approach allows you to configure the device one by one, which means that the layer 2 devices that are available here needs to be configured separately. The layer 3 devices also needs to be configured separately. Firewall and routers and every other device actually needs to be configured separately, because every device has their local control plane, has their local data plane, and has their local management plane. And that's what the limitation is, because network is becoming such a complex thing as of today that it's really hard for everyone, or it's really hard for every corporate to be able to manage and configure these devices one by one. And such kind of approach is basically very slow and it's very manual. Make sense? And that's exactly why we came out with something called SDN. Okay, that's exactly why we have software-defined networking in place. Now, software-defined networking is basically a parent technology, I would say. So, when we talk about the evolution of one network, we talked about how MPLS has been there. In order to solve something like in order to solve the limitation of MPLS, companies came out with intelligent solutions like IWAN. Cisco came out with IWAN that was called as Intelligent WAN. That kind of solved the purpose or the problems that you had into the traditional network in some extent. Okay, but then there was a company, or there was, you can say, a bunch of guys in Cisco that were working, and they left out Cisco and they created their own organization called Viptela. And this Viptela company, or the folks working in Viptela, created a solution that was basically called as SD-WAN. So when we talk about the technology SDN, it is divided into two parts. You have software defined access and you have software defined wide area network. Okay, you have SD access, or you have SD-WAN. So SD access is actually used in order to manage the LAN or enterprise networks completely. And when we talk about SD-WAN, SD-WAN is actually used in order to manage the WAN networks completely. Now there are various other vendors that came out with their own SDN solution or SD-WAN solution. So you have Cisco. Cisco actually purchased or acquired the SD-WAN solution that was actually created by Viptela. Okay, so when Cisco came out, when Viptela came out with its solution, Cisco acquired that company, and then Cisco started selling the Viptela's SD-WAN solution under its own banner. So that's why we actually called as Cisco's or Viptela SD-WAN solution. But it is actually acquired by Cisco. That's why it's being sold under the banner of Cisco itself. Okay, and then if you talk about how these SD-WAN solutions are actually created, then there are architectural factors that actually comes under it. So when we talk about SD-WAN solution, that why do we actually need SD-WAN? It is basically because SD-WAN has different controllers with it. When we talk about SD-WAN, then with SD-WAN solution of Cisco, you have different controllers. So firstly, you have a controller called vManage. Second, you have a controller called vBond. Third, you have a controller called vSmart. And fourth, you have a controller called vEdge. Now remember when I was introducing you about how traditional network actually work, I told you that almost every device has certain planes with it. So when we talk about these controllers, these are nothing but softwares or graphical user interfaces that are available that you can actually install into a data center environment. And then after installing it, you can actually access that particular environment in order to manage the entire fabric that you have. Make sense? So when we talk about this vManage, what is this vManage? vManage is nothing but the management plane of that particular uh, device, okay, of that particular fabric. vBond, however, is called as, there is a new plane that is introduced, which is called as orchestrator plane. Then you have vSmart as the control plane. And then you have vEdge as the data plane of that particular fabric. Now, the biggest advantage that you have over here is your planes, which were used to be locally, you can say, available. You had 10 routers, you have R1 connected to R2, connected to R3, and connected to R4. And then that R4 is connected to some switch, and R5 is, or R3 and R4 is connected to some switch. So over here, you have 6 devices. Now, in the traditional environment, every device will have a local control plane like this. Right? And it will also have a local data plane. Now, what is happening over here when SDN came in or SD-WAN came in? The SD-WAN centralizes the control plane that you actually had locally available on every device. It means that there is no requirement, or this is no longer like required in for configuring every device independently, which means that you have all these devices in play. But instead of that, when we look at SD-WAN solution, you have something called SDN controller. And this SDN controller actually manages the control plane centrally. And this particular control plane, you might have your switch 1, you might have your switch 2, you might have your switch 3, and you might have, let's say, your switch 4. So before that, and these switches can actually be replaced by routers as well. So before you having the solutions like that, you had your control plane and data plane locally on these devices. But now these devices, when they are connected into SD-WAN, they are just going to have the data plane locally there. So you're going to have data plane over here, data plane over here, data plane over here, and data plane over here. And the control plane that is centrally available will be managing the data plane that is locally available. So you can configure all these devices, and one devices can be in New Delhi, the other device can actually be in Dubai, the other devices can be in London, and the other devices can be in USA. So they being dispersed geographically on different locations, you actually do not really need to for a specific IT staff to be there and configure that device. Because if you talk about standard procedure, how it works, then a company purchases some devices, and that particular devices then are deployed into the production environment. They are basically configured onto the local side, and then they are shipped to the infrastructure location, and then they get installed by the network engineer that's available there. But now what you can do is you can pre-configure the controllers for the device that's going to be installed into the facility later on. And whenever the SDN controller finds that particular device online, then the controller will automatically provision the configuration that it has been specified with by the network admin, which means that you can get connected with this SDN controller from a management PC. And this management PC has the access to 4 of its controller. It has the access to the vManage, it has the access to vBond, it has the access to, you can say, vSmart, and it has the access to vEdge. These 4 controllers actually can be used in order to configure, deploy, troubleshoot, and manage all of the infrastructure that you can have into your site. That's exactly how SD-WAN works. And believe me or not, this is very much scalable. Your SD-WAN solution can handle thousands of devices that are out there. Your SD-WAN solution can actually provision multiple devices at one time. So whenever there is any change into your production environment, there is no need to go on each and every device and modify the routing policies and switching policies and firewall policies and load balancing policies in order to bring that change in effect. You can tell your IT staff to deploy how many VMs that they want to deploy, and your SD-WAN solution can just be ready by deploying the configuration from a central point of view onto all the devices that it knows about. That's exactly how SD-WAN solution actually works. Make sense what I'm talking about? Of course, each you can say controller has its own view. So when we talk about vManage is basically used to, vManage is going to be a controller where you will be doing day-to-day operation. Okay, so you will be logging into your vManage, and then by logging in, you can manage all your control planes or all your edge devices that are out there. I'm going to show you that. Don't worry. Orchestration plane, however, is something that you actually use in order to authenticate the devices that are out there. Okay, so whenever a new edge device gets connected onto the infrastructure, then that particular infrastructure will need to be authenticated that whether that particular edge device needs to be there or not. So vBond takes care of the authentication, which is being there. vSmart, however, which plays the role of control plane. So by using vSmart, you can deploy the configuration, be it OSPF, BGP configuration, routing configuration, ACL configuration, network address translation configuration, VLAN configuration, whatever configuration is that's out there, you can configure that particular thing with the help of vSmart and deploy it onto multiple devices at one time. And a vEdge basically is a controller that you can call it or you can refer it to every edge device of a site that is available. Make sense? When we talk about spine and leaf is a different thing. Someone in the chat is asking that what's spine and leaf. So spine and leaf, you can say, is deployed into a data center architecture. That's a different solution altogether, which is called as ACI, application centric infrastructure. That's not what we are following over here. This is a different thing, you can say. Yeah. Now, as we have discussed about what is this SD-WAN solution, I'll be taking you to a lab thing, and I'll show you a topology, like how it actually works, so that you can get the idea very well over here. So yeah, when we talk about that, it's time for a demonstration. So this is basically a topology that we have here. I hope you all can see my screen there. Let me have a sip of water.
Yeah. It's visible. Just one quick question, Abhijit. Someone Rishikesh asked that this is based on open source.
So yeah, over here you can see that this is kind of a topology that I have. Now, when you look into this particular part over here, let me change the color of my marker. Perfect. So this over here, you can see this is your data center hub, or this is your location where you are hosting all the controllers. So you have one vManage, you have one vBond, then you have a vSmart, and then you have a certificate or a root CA router that's out there. It's basically to ensure the connectivity between all the devices. And then you have different sites that are available. So you have site number 12. You have another site over here that's called as site number 3. You have site number 4. Then you have site number 5. And then you have another, you can say, site, or another, you can say, DC wing over here, where you are hosting a couple of services. Not a part of a site, but yeah. So what's been happening over here? Now, you can see that the vManage, the vBond, and the vSmart over here. These are three controllers that are connected with a switch, and that switch is actually connected to two type of transports. So this particular transport is a public transport, which is available there, and the other transport is actually MPLS transport. Okay, these can be two different ISPs that are available there. Make sense? So whenever you have these MPLS or public transports available, your controllers can actually communicate, or your controllers can actually be connected with all these sites by using either of the transport that is available. Wherever in the traditional LAN scenario, or wherever in the traditional network or traditional solution, you could only use single transport that is available. There was a hectic procedure if you wanted to use multiple transports inside the traditional WAN solution that were out there. But with the help of SD-WAN, you can actually ensure the connectivity between different sites by using multiple transports that are available. So in our topology, you have a public transport and you have an MPLS private transport that is available. And if you talk about the edge devices, these are different edge devices. Okay, these are called as vEdges, vEdge devices. So on site number 12, you have a high availability, or you have a edge clustering that is being done because you have multiple vEdge devices that are available there. And in site number 3, site number 4, and site number 5, you have single vManage devices that are out there that are actually being connected with the, you can say, controllers that are out there. So what's happening is your site 3 is connected to the vManage, your site 4 is connected to the vManage, your site 12 is connected like this, and your all the sites are actually connected directly to the vManage. Okay. Now, in order for this controller to recognize these dispersed vManages, vBond plays a role of authentication server. So whenever you basically configure your edge device in order to be the part of, or in order to be recognized by the controllers, that is vManage and vSmart, so that they can be provisioned with the configuration, vBond actually plays the role of authenticator. So your edge device actually needs to communicate with the vBond and authenticate itself. That is part of that particular fabric. And then the vBond gives the information about the vManage and the vSmart to all the edge devices. So that's what orchestration plane actually means. It orchestrates the edge devices that are available there. And then by accessing the orchestration plane, you can actually reach out to the vManage, and then your vManage, you can say, identifies what all are the devices that are out there by either using internet or by either using the private MPLS circuits that's out there. Make sense? So when you talk about these solutions, the controllers are not any physical entities that are out there. The controllers can be the virtual machines installed into your ESXi server, or it can be installed onto the box as well directly. Okay, so over here I have a Windows machine that is connected with that vManage, and I'm going to grab an access of that particular vManage UI, and I'm going to show you how it can actually be accessed. So if I open up my Windows machine that is actually out here, what I'm gonna do, is I'm gonna open up my web browser. And in my web browser, I'm gonna type in the address of my vManage. Just a minute. There you go. That's our vManage out there. So I can log into this vManage by using admin and admin as the credential. And whenever I log in, there you go. So you can check that this is basically a dashboard that we have here. And in the dashboard, you can check what all are the devices that we have. So we have one vSmart that is up. We have 5 WAN edge devices. If I click on this, you can actually get to know that, you see, we have our vEdge2, vEdge3, vEdge4, vEdge1, and vEdge5. And you can actually check whether they all are reachable or not. These are their IP addresses, system IP addresses. These are their site IDs that they are being recognized with. These are the model numbers, because there can be multiple models that can actually act as vEdge. Then you have BFD details, bidirectional forwarding data there, and then you have OMP. So OMP is a major protocol that actually is used, which is called as overlay management protocol. So when we talk about OMP, OMP plays a role in order to configure all the devices. All the route information is sent with the help of OMP. All the configurational information is actually sent with OMP and every other thing. And these are the version details and the control details that you have. Now, by having these data over here, you can actually click on the option and you can get the CLI of that particular device directly over here by saying SSH terminal, or you can get the real-time data, or you can check the device dashboard as well. So when I click on that particular device dashboard, it actually takes me to the dashboard where I can check the information that when this particular device was rebooted, if there was any crash, the power supply. Now the power supply and fans are not available because these are the virtual machines that are hosted. Then you have CPU information and how the memory utilization is being done of the device. You can have all the interface details. You can have the application details. You can check over here. These are the interfaces that we have on that vEdge. We have GE0/0, GE0/1 system interface, gig interfaces, and their status and all. Okay, you can also check about the traffic information, how they are performing, and you can get this real time as well. Then you have your WAN throughput, who has been the top talkers throughout the network, the T-log information, firewall information, security monitoring can actually be done, control connections can actually be managed, and every other thing can actually be done directly from your vManage. And from over here itself, you can actually select from the list which device do you want to manage. You want to manage your vManage directly, vSmart, vBond, vEdge 1, 2, 3, 4, and all the devices that you have. Make sense? So this is actually used in order to talk about how your topology can actually be managed. Make sense to most of you?
Yeah, so Abhijit, there are a lot of
So
questions
that's
coming
what
in.
an overview, or that's how your SD-WAN solution actually looks like. Okay, and by using, so what we will be doing in this particular training, when we talk about the content that is going to be covered, we are going to develop this particular topology from the very scratch when we talk about it. So you guys will be provided with the interface access that you have here. You will be able to create this topology and then configure the topology. So this is not going to be a regular scenario in the course that you will be provided with the ready-made topology like what we have or what I have over here. Everything that you're gonna get, it will all be 0, 0, 0, 0, which means that none of your device is going to be part of the SD-WAN fabric that you have. You need to do the onboarding process of your SD-WAN fabric. You need to do the configuration and provision of all the protocols that we're going to use over here. We're going to use the static routing throughout the internet circuit, and we're going to use the BGP configuration scenario into our MPLS circuit. so that the devices, the edge devices, has multiple transport in order to reach out to the vManage that it has, okay, or to the outside world as well. So you're going to configure all these topology by yourself, and then deployment procedure will be explained, and the hands-on lab for the deployment will be done. And then we'll be talking about what all are the policies, or how policies and templates and configurations can actually be done by using the CLI of these devices, and by using the GUI as well of the devices. Like you can see in the vManage, we have an option to configure the devices with the help of templates. So in SD-WAN solution, you configure the device by using template. Okay, and when we talk about templates, there are device template and feature template. So feature template is like you can create a specific template for every feature that you want to have. Okay, like what we have over here is we have a template for BGP configuration. We have a template for VPN configuration. We have a template for, you can say, banner configuration, for interface configurations, for every other configuration that you can actually have. And by using this template, you can actually create your device templates and attach these templates to the devices. Like you can see that over here, I have 3 device templates. One is MPLS only, single device only, and you can say dual site only. And these 3 templates are attached to different devices. So you can say the MPLS template is attached to one device. The single device or the single site template is actually attached to 2 devices, and dual site template is also attached to one device. So you can attach these templates, and then the multiple devices can actually be configured by using these templates. That's one of the way that you can actually use your vManage or your SD-WAN fabric to be configured with. So the part of the configuration by using either CLI or by using the templates is also going to be there inside your course. And then how to bring this vManage up and how to connect all the devices together is of course going to be the part of the scenario where you will be working, because in the beginning the control up will be 0 and the control down will be 5, and then you actually work it the way to bring it into partial and to make it into the full, which means then the vManage solution centrally has the control of all the vEdges that are out there. So that's exactly what the scenario looks like, and that's how your SD-WAN solution actually looks like, and this is what the topology is going to be. However, we'll be making some tweaks into the topology that we have over here, because this is kind of a testing topology that I'm using, but pretty much it's going to be almost the same that we have here. This topology covers almost everything that you can do into your SD-WAN fabric. So yeah, that was basically the scenario that I had to discuss with you. And now it's time for your questions or Q&A. And on my screen, you can also check our upcoming batches for the SD-WAN solution, okay, which will basically be starting from 1st of March for the weekdays, and you can find about the other batches that are being conducted over there as well. Meanwhile, I'll check out your questions and I'll try to answer your questions, whatever are there. So, Dipanshu, if you have noticed any specific question, just a minute.
Can you hear me now?
Just a minute, Dipanshu.
Sure.
I'll probably need to plug my earphones up in order to hear your voice.
Yeah, I understand. Yep. Can you hear me now?
Yeah, I can hear you, Dipanshu.
Okay, there's a bit of echo, but it's okay. So I've just noted down all the questions, and let me share my screen, and so that you can have all the, or let me just read it out for you.
Sure.
So first question is, controllers are the physical devices or can be used using VM? But you have already answered that. I think Raj has already.
It's the VMs.
It's the VMs. So another is, so SD-WAN is for enterprise edge routers to move control plane to central location.
Yes, that's correct.
Okay. Another question is, this is based on open source?
No, it's a closed source configuration. The rights are completely reserved by Cisco.
Okay, great. Another is, all sites are connected to vManage using public internet or MPLS.
Well, that can be configured. That can be basically connected by using public internet as well and MPLS as well. So you can have any type of transport in order to connect multiple sites together. Okay, like I showed you over here. We have 2 transports over here. One is public internet and the other one is MPLS. So if any of the transport goes down, the alternative transport can actually be available in order to keep the connectivity between the vEdges and the controllers up. So you can use your cellular network, you can use your public internet, you can use your private internet. It doesn't really matter. We have redundancy over the type of transports that we have, and that's how I'm keeping the connectivity up there.
Okay, great. So another is like during onboarding, Viptela device first contact vManage or vBond or vSmart.
Well, it contacts the vBond first in order to like become the part of the SD-WAN fabric. If it successfully does the authentication, then vBond provides the information about where vManage and vSmart can be reachable, and then the device gets the information about those controllers, and then it connects with them.
Great. Okay. And it say he also asked like, Ajay, this is Ajay's question. So please tell me protocols used by devices to contact each of them. I think this would be an explanatory answer.
Well,
Can be
yeah,
really.
this will kind of be a like a bigger topic, I would say. But OMP is a protocol that actually is used in order to communicate with the vSmart. Then there is, you can say, DTLS tunnels that are built with IPsec between the, you can say, data plane connections and the control connections. So when you talk about these vEdges, all the vEdges are connected with the controllers by using tunnels. And those will be IPsec tunnels that will be created. So it can be TLS tunnels or it can be DTLS tunnels that are out there.
Great. So another question by Nitin is, can SD-WAN be implemented in the current running network?
Yes, it can be. We are going to talk about how the migration is actually done. So from traditional to SD-WAN, how the migration is done, that will be the part of the course.
Got it. So now this question came from Roshan that brief on OMP protocol, please. But I think that this will again be a big topic to explain for this webinar. Yeah.
Yeah. But all I can say about OMP is actually a protocol that is used in order to pass on the control plane traffic. For example, the vEdge1 over here, or let's say on side 3, you have your a router is available here, and this router has multiple networks that actually needs to be advertised to everyone out there. So people over here needs to communicate with the people available in site 12, site 5, and site 4. So OMP protocol will be responsible to take that particular information from that vEdge, and then the information will be provided to the vSmart. And by using OMP protocol, vSmart will be forwarding all that information to all the sites that are available there. So that's kind of a glimpse of how OMP or what OMP actually is responsible for, to forward all the control plane traffic or control plane information to every other vEdge that's out there.
Got it. Okay. So another question that just came as well as it was there earlier as well, like, it's a mix of 3-4 questions actually. So what is the difference between traditional MPLS or SD-WAN MPLS or INT connection or, it's NMS? Why don't we use NMS network management system to monitor or configure these devices? So it's a mixed question of 2-3 questions that came.
Well, I would say that MPLS is not something that is actually acting as a replacement. What's happening is MPLS was kind of a private circuit based connection, which means if you have MPLS, then you could say that your data is actually being securely transported. But now SD-WAN actually helps you to not use MPLS in your system. It's fine if you're using that. But if you do not have MPLS solution, even then you can rely on the public internet because all of your traffic is actually secured by using tunnels. So that's why you can have MPLS and still continue to use SD-WAN. You cannot have MPLS and still continue to use or try and bring in SD-WAN into your solution. That would kind of solve all the benefits, or that would also give all the benefits that you had by using MPLS over the public internet as well. So yeah, and NMS, we can use NMS, but SD-WAN gives you better ability to manage the entire network. So NMS still was a limited approach in order to manage the control plane or in order to manage all the devices that were out there one by one. But SD-WAN kind of gives you an ability to manage all the devices one at a go. So you can create a template or you can create configuration for once, and you can deploy that particular same configuration on many devices at the same time. That's why SD-WAN's controller, our control plane operations are better than other things that are out there.
Got it, noted. And another question that came was, can we apply Viptela knowledge to other vendors like Versa, Nokia, and other, like what we are learning in this SD-WAN, right?
So the technology is same. If you learn about SD-WAN, it's gonna be the same on the other vendors as well. The structure and the architecture is same, that you are using controllers in order to manage the fabric that you have, or the WAN fabric that you have. It's just gonna be the different methods of how they are deployed, or different UI, or different, you can say, methods of configuration deployment that's gonna be there. If you learn about Viptela solution, it will be easy for you to also know about the Versa or the VMware or Citrix or other vendors SD-WAN solution. So that can be an add-on for you, I would say.
Great. Okay. And I'm skipping a few questions that are already answered as a part of, other questions. So I'll just skip questions now. So one is that, what is the minimum RAM requirement to set up this lab on a laptop? So it's a big question, I think.
Well, I would say more than around, say, 40 gigs of RAM would be needed, because your physical computer doesn't work the way a server works. So this kind of thing, or this kind of topology, actually requires around 40 GB of RAM, or at least like 32 GB of RAM, for your computer to be to have, and that entire 32 gigs of RAM needs to be dedicated to this topology. Then what would your PC have? So that's why it's, if you have a big RAM, and because you can have RAM installed on your laptop, but the number of CPUs that needs to be dedicated for the topology, you cannot really have that on a local computer. You need to have like a 16 vCPUs, or like a completely 8-core processor dedicated to one single topology, and then your computer would be non-responsive if you dedicate all the cores to the topology. So this type of labs can be tested onto the labs in a better way. Otherwise, your topology will come to a standstill, and it will take like a minute or 2 minutes to even pass on the single instruction to the topology.
Right. And I'll just add it up that that is why we are giving our own labs here for this training.
Yeah. Everyone will be getting their own hands-on lab, and they can work on the topology individually, one by one.
Yeah. And one question that came from Deep earlier was, and now again was, it's like, what is the use of SD-WAN if companies are already using MPLS for underlay communication over SD-WAN?
Well, by using MPLS, they still need to configure the devices one by one going on every site. It's not like MPLS is allowing them to configure all the devices from a centralized point of touch. So that's still a limitation that you have in traditional WAN networks, even having MPLS on board.
Got it. And are we going to cover security features in this course, and does it require additional licenses?
No, it doesn't require additional licenses, and we are going to cover some of the security part as well. That's how about SD-WAN security.
Okay. So what are the monitoring options that we have for SD-WAN, and how can we get the monthly reports of the network performance, or is there any analytics engine with the Viptela?
Yeah, you actually get a something, you can say, you actually get vAnalytic as one of the tools that's available over here. And by using this vAnalytic, you can actually get to know about how your network has been performing, and you can actually predict what needs to actually be done based on the history of your network performance. So this vAnalytic tool in your SD-WAN solution can actually be used in order to get to know about the network performance and network audits. It can give you complete graph. It can give you every information about how your network is performing. Yeah.
All right. Okay, great. And then rest are almost similar, but yes, one is there. So does Viptela does Viptela provides L7 visibility? If yes,
it does.
okay. If yes, then it requires more processing power.
Well, yeah, you can say it requires more processing power, because you will be using additional tools as well along with it. Because there is also the next phase after deploying SD-WAN, that is called SD-WAN programmability. So by using REST API, you can integrate multiple tools with your SD-WAN solution in order to do layer 7 inspection and every other thing that's out there.
Got it. And one question from Srinivas, that any hardware/OS requirement in router to support SD-WAN?
Yes, there are specific requirements that you can that they have. You can use either Viptela devices, specific devices, or you can use Cisco devices that can actually act as the edge routers. So we'll be talking about that in detail into the course itself.
Got it. Okay. So now I'll club two questions for you, Abhijit. Why both MPLS and ADSL line are required? And is MPLS not cost effective for SD-WAN? So I mean, it's around MPLS and ADSL and SD-WAN only. So if you can just quickly take a
when you talk about ADSL or even about MPLS, these are specifically about the transport, how traffic will be sent from one location to the other location or one side to the other side in a secure way possible. However, when you implement SDL, also SD-WAN, then in SD-WAN, it already solves the purpose of sending your traffic from one location to other location in a secure way possible. So that eliminates the needs of either having ADSL or having MPLS there. But even if you have it already deployed or it's part of your service from the ISP, you can still use SD-WAN in order to manage your network in a central point of view. You can manage your control plane from a centralized controller that actually eliminates the need of having the devices be able, like the devices being accessed and controlled one by one. So this is not a comparative factor that you actually need to do. SD-WAN is a different thing than MPLS and ADSL that's out there.
Right. Okay. So another point is like, how we will be doing the labs. Will it be virtual on our systems as RAN will not permit the requirement? So I think it's like Das Prayesh, you will be accessing it through your own Google Chrome browser and you'll be accessing our labs.
So we will be providing a remote access of our labs and you can connect with directly the topology that you're going to have here and you can get the access into your Google Chrome itself. Okay, so you'll be getting the CLI of all the devices and you'll be getting the GUI of all the controllers directly into your web browser itself. So yeah.
Great. So can we manage different vendor devices using vManage or just Cisco/Viptela devices?
Yeah, it's just Cisco/Viptela devices that you can manage.
And what about Versa or let's say another other? So there is a different.
Then you will be using different controllers, right, for that. Okay. So Versa has their own set of controllers that can actually be used in order to manage the Versa devices.
Good. Can NGCS technology be considered as an SD-WAN?
NGCS, what's NGCS?
Find it out what is this technology exactly, because there are a lot of keywords that exist.
Next generation can be NG.
Yeah, next generation core services. I mean, that's a generic keyword actually. Sahil, can you please explain once again what you are exactly looking at? Because it's a kind of a word that's a generic keyword. Anyways, I'll move on to the next question. Where Juniper routers having both capabilities of MPLS and internet? I don't know. Is this related to SD-WAN?
No.
Then we'll just skip it for now.
Juniper doesn't come in play when we talk about Cisco's SD-WAN solution.
Yeah. So is Viptela and 128 technology have same approach?
No, they all are different, I would say. The underlay technology or SDN or SD-WAN technology is same, but the way that the devices are being managed or controlled are quite different between them.
Got it. Okay. Yeah. And do we require MPLS knowledge to learn SD-WAN?
Well, if you have it, that's an add-on. If you don't have it, that's still good. Fine. I'll be explaining the minimum thing that you actually need to know about MPLS in this course.
Right. So and it's like if you have basic knowledge of CCNA, CCNP, and other, like you have an experience in the network engineering background, your background, so it's more than enough for you to start with this.
Yeah.
So another one by Brahm is that can it be run on Huawei and Cisco routers all together?
Well, you can have your Cisco routers inside, but you cannot really have your Huawei devices acting as the edge devices. That's not really possible.
Okay. Now, then there is a technical question by Roshan. It says he's already working on Systrom SD-WAN and have done migration. So, Roshan, I'll suggest you can email us this question. And if you want us to look into your scripts or something, we can just look into it offline, not in this webinar right now. But yes, we can help you out for sure. And Ramesh says, can SD-WAN run over internet?
What is that question?
I'm trying to understand that. Ramesh, please explain what you're trying to say in this question actually.
You might be asking that can it be done on public internet? Yes, it can be. You can have your public internet connecting your multiple sites together. So yeah.
Right. So Ajay is asking, and it's a lovely question, that may I know the use cases of Viptela? Why should customer go for Viptela for larger deployments or SOHO sites?
Well, Viptela is also coming, or Viptela is also going obsolete now, and the devices are actually Cisco is in talks with Viptela in order to combinedly create a new set of devices that can actually be deployed onto the edge devices. But Viptela has created this solution, and Viptela uses less of the resource power in order to be deployed onto the WAN devices. That's why it's kind of a pact. It's kind of more inclined towards the business between Cisco and Viptela. Why you are having. If you do not want your Viptela devices to be there into your SD-WAN solution or to be there into your edge devices, then you can completely go with Cisco's ISR routers or ASR series routers, or you can even go with CSR series virtual routers that can be out there. It's nothing like you need to go with Viptela. You can skip that.
Okay, all right. So another one came. I think this would be the last one. Okay, said like he'll be emailing us his query, technical queries. Please do email Roshan. And this came like, can vManage and vCloud controller talk with each other? I think vCloud is the SD-WAN of VMware, right?
vCloud is the you can say VMware.
VMware, yeah.
Yeah.
So can they
So,
talk together? Yeah.
well, I don't think they will be able to talk with each other. But if you use services like REST API, or you create a third-party tool that actually collects information from both of them and shows it to you, or you can, however, control both of the solutions by using Python, but not directly communicate. Like they cannot talk directly with each other, but they can talk with each other by using REST API or something like that.
Good. So I think that answers the next question automatically. Can we use vManage to talk to other vendor controllers, maybe using APIs?
Yeah,
Yes.
maybe using API. That's what I said.
Got it. All right, fine. I think all the answers. I mean, I tried not to miss any question. I was trying to scroll up and down again and again. All right, fine. Please let me know if there are any offers or free courses available for SD-WAN. Ajay, we are using. I mean, this course is going to be a paid course, and the batch details are right in front of you. We're starting from Monday to Friday, 1st March, and then another weekend batch is coming from 13th March. Anyway, so now the point is like, if you need any advice or any, if you want that kind of discussion, like, pricing or any discounts and all, you can always reach out to me on WhatsApp. This is my WhatsApp link. If you click here, you'll directly come to my WhatsApp automatically, and or you can email me at dipanshu@pinetlabs.com, or maybe you can WhatsApp or email Nitish. I think you're already in touch with, most of you are in touch with Nitish already, so you can always message him directly. Yeah. So Abhijit, last question. I'm sorry. Sunil is saying, can we use Cisco high-end switches for vEdge?
Well, there are specific set of devices that actually needs to be done, that needs to be used, and those are ISR or ASR series routers itself.
Okay.
Higher end switches can be used in data center solutions like ACI or so, where we talk about Nexus switches, but not as edge devices.
Got it. And so cloud versus SD-WAN learning for network engineers. Ankit, I think both of them are different. Like, it's related. Yeah. So like I shared my number just now, you can always call me and we can like, speak in length about it, that how cloud and how SD-WAN is working differently. Fine. All right. All right, guys. Thank you so much. Thank you very much for joining in, tuning in. And thank you so much, Abhijit, for your time.
Thank you so much.
Yeah. I'm glad that, even you won't believe, Abhijit, like 93, 94 people joined at 5:30, 5:25 itself. And 75 people are almost there in the batch. Yeah. So it's good. I mean, right now, like it was 94 10 minutes back. Anyways, thank you so much, Abhijit, for your time. All the best.
Thank you, everyone.
Take care.
Thank you, everyone, for having me, and looking forward to see a lot of people on board on our trainings. Perfect. Thank you, everyone. Take care of yourself. Be safe wherever you are. Okay. Take care of your family, and I'm looking forward to see you guys on board on the trainings. Thank you. Take care. Bye bye. Thanks, Dipanshu. Bye.
See you. Bye. Thank you so much, everyone. I'll just reading the comments meanwhile, and also leave. All right.